So we're going to be reviewing using the quadratic formula to solve quadratic equations. So in order to use the quadratic equation, we have to write the problem in standard form. So I'm just going to put up a problem. 3x squared minus 5x minus 7 equals 0. Okay, we always want to write our problem so that it looks like this. Ax squared plus bx plus c equals 0. Now you may have to do some, like polynomial multiplication or some other operation to make your polynomial look like this. For our case, we have a equals 3, b equals negative 5, and c equals negative 7. Okay, now I'm just going to highlight how we know that these terms are. So here's a and 3. Okay, a equals 3. And we got negative 5. B. So b equals negative 5, as we see here. And then negative 7. C. So we see that c equals negative 7. Okay. So let's use the quadratic equation. I know that most students have committed the quadratic equation to memory. And so it goes like this. Okay, so x actually has two values, right? Because there are two solutions to a quadratic equation. Why do you think there are two solutions to the quadratic equation? Think about the fundamental theorem of algebra. Well, quadratics are second order, and the fundamental theorem says the order of the polynomial is also the number of roots. Okay, so we got minus 5. Plus or minus negative 5 squared minus the product of 4, and that will always be 4. It's part of the formula. Times 3, which is a here, and times negative 7. And this all remains under the radical. And all divided by 2a, and here a is 3. Okay, so we can just evaluate this numerically. We're going to think about sign arithmetic. So minus 5 is plus 5. Plus or minus. So the only problems here are really sign arithmetic. Minus is plus. A negative times a negative is a positive. So we got negative 5 times negative 5 is positive 25. We got two negatives here. So we get 28 times 3. Okay, so 25 plus 84. And then all divided by 2 times a. Okay, well actually we can go ahead and just write 6. Okay. So this means that, 25 plus 84 is 109. So we know that our two roots are as such. If we want to be real specific, just to make sure we all understand what plus or minus means, we can say, well, x has two values, x equals 5 over 6 plus the square root of 109 over 6. And we can use a subscript to denote the two roots. Okay, so these are both solutions. And we're going to be talking about complex arithmetic because sometimes the discriminant, which is this part under the radical, it's called the discriminant, is negative. And then you have to take the square root of a negative number, which we know yields an imaginary number. So b squared minus 4ac is an important quantity, and we're going to talk about it in 1 second.